the other CHs, this is the hydrogen that's coming off of the double bond. So this is the CH stretch. The sp3 hybridized, the alkane carbons are all the ones that are coming at around 3,000. We're talking about organic molecules. We always have them. You can mark it, you cannot. What I would be interested in is that you can tell me that you have the alkene and that you can show and confirm that with the hydrogen coming off of it. If it's part of your problem, you've already gotten a portion of the points just doing these two things. We know that we have a double bond. What ppm value does your double bond come? The hydrogen's off in the proton bond. This is when you would turn to table 13.3. So proton NMR. If we go through and find a hydrogen that is vanillic, coming directly off of that carbon, it tells us we are in the 5 to 6 range. So we know that these two signals are in the vanillic region. How many total hydrogens do we have coming off of this double bond? The numbers at the bottom here, the 1H2H, that's your integration value. That tells you how many protons each signal represents. The one on the left is 1 hydrogen, the one on the right is 2. It's a total of 3. We have a CH2 that is vanillic. We know that this has to be terminal then. Those two hydrogens have to be equivalent. In this one, my M is standing for a multiplet. This is usually more complex splittings that I don't expect you to know. But we also have a doublet. The doublet, we know is representing the CH2. These come as a doublet because the carbon next to it only has 1 proton. That we already knew though. What is the signal at 3.5? What is this carbon that these hydrogens on? What are we going to be attached to? If you look at your table, 3 to 4 is attached to X, where X equals halogen or oxygen. We look at our formula, we don't have oxygen. It has to then be chlorine. What type of carbon is this? CH, CH2, CH3. Again, look at your integration value. It's a CH2. If you have something, and we're going to talk about this triplet in a second, and it's a part of a chain, either box in or underline the protons that the signal represents. What does the triplet tell us? This is my n plus 1 rule. Triplet's 3. I have to go backwards. 3 minus 1. portion of the molecule. How many bonds do halogens get to be neutral? They only do one. We know this then has to be the end of our molecule. We can't carry on that way anymore. We know that this CH2 has 4 bonds. Nothing else can come off of it. We are next to a CH2. Well, that needs 1 more bond. If we're looking at the alkene, the CH2 on the right-hand side, 4 bonds, that's the other end. We have 1 signal left that we have not touched on. It again is a CH2, based on our integration, and it's a quartet. How many protons am I next to? We have a total of 3. Well, if we look at our PC parts, we have to get a total of 3. We're CH2. Just looking at this signal, we may not know if we are attached to CH3 and on the other side we don't have any hydrogens, or we're in between CH and CH2. If you look at your integration values, we don't have anything worth 3 hydrogens. We know it can't possibly be the top option. If we look at the 2 pieces, we do know. Again, we know that these have to be the 2 ends. We needed another CH2. The CH2 here is the signal just below 3. This CH2 is connecting the 2 portions together. Again, if you can get just these portions, that's part of the points. Being able to tie it all together is a fraction of the total. Again, we were able to solve the problem without ever looking at the carbon. Quite often we can. You can verify that we do have functional groups initially, but we do want to go back and assign our peaks. Yes? Yes. Yeah. Make sure, even if you don't need it, make sure you do go back. That's going to be part of the points. With the carbon-13, we didn't look at it as much. The table that you have isn't truly a table, it's just that diagram with the broad ranges. You may not necessarily be able to identify which carbon exactly is which. In some of the cases, if they're ambiguous, if it's something that you wouldn't necessarily know, and you get them backwards, it's no big deal, you're still going to get the points. Or, in this case, if you said that these are in the alkene, I'm going to give you the points. You're telling me that those are the 2 carbons in the alkene region. That's the information that I want you to get from the carbon and Mars. Here, you should be able to identify which is which signal because of the alkene. So if I make these A and B, the carbon directly attached to bromine, you're attached to the electronegative atom, you're more de-shielded, you should have a higher ppm value. Within the instructions for the final problem, where the points are coming from is clearly indicated. So then just go back through and double check and make sure you touched each of the points that I've addressed. If you do that, you're going to then go, oh, I need to write something